This simulation is a way of testing to see how metals react when they're heated. So I'll quickly go through a few of the things just to show you how this works. At the bottom here, I can change the name of the metal. So I've got aluminium, I've got copper, and I've got iron. That is my independent variable that I'm going to investigate. I'm going to see how each of these heat up. I've also got a thermometer. That's for measuring the temperature. That's going to be my dependent variable. I can also change the voltage on the supply that is heating up this heater. This heater here is like the heating element in a kettle. So to keep this test valid, I'm going to keep this at 12 volts. That will leave the current going into the heating element at 4.17. So two control variables are going to be the voltage that I'm supplying and the current that it's drawing. Okay, so along here, I can change how long the temperature has been heating the block. So if I move the temperature along one bit, you should see that the temperature here went up a tiny little bit. Okay, so let's reset the time to 0. Okay, so what I'm going to do is I'm going to control the voltage and the current. I'm going to change the block and I'm going to measure the temperature. So for each experiment, for each block, I'm going to slowly move the heating time across and record in the graph here what's going on with the temperature. Okay, so my first small movement is 30 seconds on the clock. So I'm going to plot that point. So as you can see, it's plotted a point in red for the aluminium block. I'm going to move it to 60 seconds, which is 1 minute. So I'm converting the time in minutes to seconds. I'm going to plot the point. I'm going to carry on moving across with the time, plotting the points as I go. And as you can see, as the temperature rises, the points move upwards. At the moment, it appears to be a straight line. I'm going to carry on going until I've done all the time available to me, which is 600 seconds, which is 10 minutes. Okay, so all the way along to 10 minutes. So as you can see, as I increased the amount of time I was heating for, the temperature of the block went up. What I'm now going to do is reset the experiment to then, and I'm going to change the block. Notice that I'm starting at the same temperature for each block. So that means that my control variable starting temperature is controlled because it's always at 20. So now I'm going to do the same thing, but I'm going to do for the copper block. So as we move across the graph, you can see the copper is being plotted too. So it started off the same. Now it is going up faster. So the rate of change of temperature with time is increasing because I've got a steeper graph. So now you should be able to see that over my time, I've got to a higher temperature. So the temperature for aluminium got to around 50, but the temperature for copper has got to around 90. So I have one more experiment to do. I'm going to quickly do that for iron. Exactly the same thing. Measuring the temperature at 30-second intervals, plotting them on the graph. You can see these as the blue dots moving up the page. So same thing again. Don't forget, I'm controlling the time because I am deciding when to do the measurement. So the iron block is now in between the other two. So the easiest block to heat was the copper block. The hardest block to heat was the aluminium block, because in the same amount of time, for the same amount of energy being given, the copper block, the aluminium block has got less temperature rise than the copper block. At the beginning, something strange is happening. Okay, so let's go back to the beginning of the lesson and let's have a look at what's going on with the temperature to start off with. So for the first couple of increments, the temperature changes aren't that big. So they're only changing by small amounts. So the question is, why is this happening? Well, if you think about it, for the block to get hot, I have to first heat up the element. The energy that I'm giving to the block has to then be transferred through the block to the thermometer. So the thermometer will only measure the temperature change when the heat gets to it. So the beginning of the graphs are not part of the experiment that we are looking for. We are looking for the slope of the straight line graph. Specific heat capacity is a measure of how much energy I need to increase the temperature of a block of 1 kilogram by 1 degree C. So if I want to raise the temperature of aluminium by 1 degree C, I'm going to need to give it more energy than I did for the copper. So out of the three metals, aluminium has the highest specific heat capacity because it needed the most energy to heat it up. So if I was trying to heat them all to 40, which is here, you will see that the aluminium got there fastest, so that needed the least energy, then iron, then copper. So the steeper the line, the lower the specific heat capacity for that particular object.